Welcome to this lesson on hydraulic systems. Today we will explore how fluids can be used to multiply forces, a principle that powers many machines around us, from car brakes to heavy lifting equipment. This fascinating application of fluid mechanics demonstrates the incredible power of physics in everyday life. The foundation of hydraulic systems is Pascal's principle, discovered by French scientist Blaise Pascal in 1653. This principle states that pressure applied to a confined fluid is transmitted equally in all directions throughout the fluid. This means that when you push on one part of an enclosed liquid, that push spreads uniformly to every other part of the liquid, creating equal pressure everywhere. Before we dive deeper, let's understand pressure. Pressure is defined as force divided by area. The formula is P equals F divided by A here. P represents pressure measured in pascals or newtons per square meter, F represents force measured in newtons, and A represents area measured in square meters. This relationship is crucial because it shows that the same force applied over a smaller area creates higher pressure. A basic hydraulic system consists of two pistons of different sizes connected by a pipe filled with an incompressible fluid, usually oil. On the left, we have the input piston with a small cross-sectional area, labeled A1. On the right, we have the output piston with a much larger cross-sectional area, labeled A2. The fluid connects these two pistons, allowing pressure to be transmitted between them. Here is the key concept. Pressure is the same throughout the confined fluid. According to Pascal's principle, the pressure at the input piston, P1, equals the pressure at the output piston, P2. This equal pressure transmission is what makes hydraulic systems so powerful. Even though the pistons are different sizes, the pressure remains constant throughout the entire system. Now let's derive how force gets multiplied. Starting with P1 equals P2, we substitute the pressure formula. This gives us F1 divided by A1 equals F2 divided by A2. Rearranging this equation, we get F2 equals F1 multiplied by A2 divided by A1. This is the force multiplication formula. Notice that if the output area A2 is larger than the input area A1, the output force F2 will be greater than the input force F1. Let's work through a numerical example to see force multiplication in action. Given an input force of 100 newtons, an input piston area of 0.01 square meters, and an output piston area of 0.1 square meters. Using our formula, F2 equals 100 multiplied by 0.1 divided by 0.01. This simplifies to 100 multiplied by 10, giving us an output force of 1,000 newtons. A small input force of 100 newtons has been multiplied tenfold to produce 1,000 newtons at the output. One common application of hydraulic systems is the hydraulic lift used in automobile service stations. Its function is to lift heavy vehicles using a relatively small input force. The key principle is that the large piston area multiplies the input force significantly. A mechanic can apply a modest force on the small piston, and the hydraulic system amplifies it to lift vehicles weighing several tons with ease. Another critical application is hydraulic brakes in vehicles. The function of hydraulic brakes is to apply equal braking force to all wheels simultaneously. When you press the brake pedal, pressure is created in the master cylinder. This pressure is transmitted equally through the brake fluid to all wheel cylinders, ensuring uniform braking. This equal pressure transmission makes hydraulic brakes reliable and effective for safely stopping vehicles. Let's review the key takeaways from this lesson. First, Pascal's principle enables force multiplication in hydraulic systems. Second, a small input force can lift heavy loads by using pistons of different sizes. Third, incompressible fluids transmit pressure equally throughout the system, which is essential for the system to work. And finally, the area ratio between the output and input pistons determines how much the force is multiplied. Understanding these concepts helps us appreciate the engineering brilliance behind hydraulic machines that make our lives easier.
If you like this video, Hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.